Hi, this is a quick video on intersections, unions, and compound inequalities. So let's start right away with an intersection. The word for intersection that you're looking out for is and. And means that they are both included, just like on a road's intersection where two streets cross over each other and you can stand in the intersection and be on both roads at the same time. Here we have -2 is less than x minus 3 is less than 4. I can't graph this until I get the x alone. So the next step is to find what's happening to the x and undo it. Here we're adding 3 to both sides to undo what's happening to the x. I do it to all 3 terms. I have to do it to all 3 terms. Here, because I'm not dividing anything or multiplying anything by a negative, I end up with the arrows facing the same way, the inequality signs to be more proper, and I have this. Now I can finally graph this. So I'm going to cover up one side of this, and I'm going to look just at this side and graph that. So here's my number line with my 0. I always put in numbers underneath, and I start at a positive 1, and I color it in because of this less than or equal to. And then I use the words what number to figure out what's going to work for my graph, which way my graph is going. So the question is, what number is 1 less than or equal to? Here again, 1 is less than or equal to what number? Well, to answer that, 1 is less than all of these numbers. So I put my arrow going this way. Now I go ahead and do the other side. I'm only looking at this right now. X is less than 7. So I graph my 7. Let me do it in this color. Here's my 7. And I put an open circle because it is just a less than sign there. And again, I use the words what number is less than 7. All of these guys are less than 7 going this way. Because it is an and means that I have to have the place where it includes both of them. So it is just this part here. Even though these arrows would go in, these are actually raised, correct, so they go on forever. We're only looking at the intersection, so we're just looking at the and part of this, where they both are connected. Next thing we can discuss is the or. So or is a union, and so they may both be on the number line discussing relationships with x, but they don't have to be together. My example that I kept using today was to get in half price for a movie, you have to be over 65 or under 10. You don't have to be both of those. It's impossible to be both of those. So let's do an or graphing here. Here is my or. I'm going to put my number line down. I put a 0. My first number on this side is the 2, so I put my 2 in here, open circle, because that's a greater than sign, and then I ask the question, what number is greater than 2? So again, what number is greater than 2? All of these numbers are greater than 2. Then in a different color, I'm putting down my -1. Looking at this, what number is less than or equal to a -1? So the answer to that, it's all of these numbers are less than or equal to a -1. So that is a compound inequality with an or a union. This is a great time to talk about one, and that is the words within or between. So when we're talking about within, we are using a less than or equal to sign or a greater than or equal to sign. The key thing here being the equal to sign. So if I were to say within 20 to 40, I would include the 20 and the 40 in my counting. Between is a different story. Between, we do not include the equal to. So between is a less than or a greater than. So what I could do is say x is between 20 and 40. I would put my x in, and I would have 20 on this side and say 20 is less than x, and x is less than 40. So let's do one example here. We want to solve this and graph it. It says negative 2m plus 7 is less than or equal to 13, or 5m plus 12 is greater than 37. To solve this, I am going to get the variable alone. So I'm subtracting 7 from both sides. I get negative 2m is still less than or equal to 6. And then I'm going to divide by a negative 2. Remember, when I divide by a negative, it switches to face the other way. Reason for this being that as our numbers get smaller on the negative side, left side of the number line, left side of 0, as the numbers are smaller, they look bigger for their absolute value. Anyway, on this side, I'm subtracting 12, and I get 5m is greater than 37 minus 12 is 25, and then I divide by 5, and I get m is greater than 5. This is an OR situation, so when I graph this, I'm not going to include only the parts that are common to each. I'm going to include all of each one of them. So here's my 0. I'm starting at a negative 3. It's an greater than or equal to. So my line starts going off like this. What you see unique here is that this is 5. That's an open circle. And it also is going in the same direction. So my graph of this will be a single line, and it actually will go right through this open circle here to include it, because that's part of this ray. So now just make that into one single ray going out here, and that is my compound inequality that says that m is greater than or equal to negative 3, or m is greater than 5, and in this case it's both of them. So if both of these are true, or even if just one of them is true, then the statement is true. Good luck.